Okay, welcome everybody. It's 10:03 actually, so we are going to begin. As I say, anytime we have a webinar, it is never lost on me how valuable your time is, and we appreciate taking time out of your day to join us. This is going to be an interactive webinar in 3 parts. The first part is going to be revealing the science behind nanobubble technology, and then specifically how it improves agricultural efficiencies and better outcomes. We'll talk about the process that we use when we interface with our customers. And the second part will be the actual utility of Moleaer to agricultural systems. We will talk about different crops that we have treated, and again, how we operate in terms of our objective-based consultative model. And then the third and the most important will be an interactive question and answer period. This is an hour-long webinar. For those of you just joining now, I want to point out that this is being recorded. So if you have colleagues, we can always send it out and we will post where you can access it. But also you should know that we would appreciate it if you would mute yourselves and your phones. In terms of housekeeping, if you look around, you'll notice that we have provided restroom facilities for everybody. So if you need to use the restroom facilities, there shouldn't be a lineup there. So we're going to start. There's a lot of information to go. In terms of the next slide, we will let you know. Warren, advance the next slide, please.
Give me a minute. Dan, 1 second, Michael. There you go.
Okay.
Okay, let's go up.
So this just as an introduction, we will cover this much more in the latter half of the presentation, but we just want to put a few little bullet points in the front of your mind as we go through this. And what I'd like you to do, actually, those of you who work in irrigation, which is everybody here, is to keep some of these objectives and the accomplishments that this nanobubble technology can actually bring to you in mind. And I want you to add your own to it as we go along. Ask questions. Will it do this? Will it do that? So I'm not going to read the slides. Nobody reads slides in professional webinars, but you should look at these 5 categories, and we will go over them in much more detail as we go on. So the first part, going into the science, you will have the pleasure of meeting Warren Russell. Warren is Moleaer's co-founder and chief commercial officer. He's an experienced entrepreneur. He has 20 years of business experience management in the wastewater treatment and environmental service industries around the world. Prior to leading the commercial efforts for Moleaer, Warren, who is a graduate of the University of South Africa, founded 2 firms focused on environmental consulting and designing wastewater treatment systems for municipal, industrial, oil, and gas applications. I think you all know me. I was very, very happy to join Moleaer only a few months ago, as Moleaer decided to expand the application of nanobubble technology, which has proven itself in surface water treatment, in mining, in oil and gas, in aquaculture, and also in horticulture. But we decided to expand to outdoor agriculture, and we now know that we are crop agnostic, and we can provide benefits to any crop, and especially important to note, in virtually any irrigation regime. This is not limited to subsurface drip irrigation. We have great successes in microsprinkler applications. We're looking at center pivots. So there's really no limit to the possibilities of using nanobubble technology, again, for any irrigation regime, including turf, including almonds, including grapes, including alfalfa, any crop with virtually any irrigation regime. So keep that in mind as we go along and you start thinking of applications. So I will talk more specifically about agriculture as we go on, but I'm going to turn over the microphone to Warren, who'll go through the science of nanobubble technology.
Thank you, Michael. Good morning, everybody. I appreciate everybody's time and participation this morning. As Michael said, we know you have lots of other choices to be doing right now. So I will get to the point and make this as succinct as possible. And as I said, you know, if you want to save some questions to the end, happily address any questions that you may have. So as Michael was explaining, Moleaer was really founded around the principle of a nanobubble technology, and we've commercialized applying nanobubbles in a variety of different ways, typically in an aqueous solution. We've had tremendous success in treating irrigation water. A lot of the times it has to do with improving water quality, but what we focused on today is really around the surface tension reduction capacity of the nanobubbles. And Michael was pointing out, we've really got these 5 key principles that apply to irrigation water and soil health and plant health. And it starts with introducing nanobubbles into the irrigation water. We're principally focused on surface tension reduction. That, as a consequence, has impacts on the penetration, soil compaction, potentially sodium mobility and leaching that sodium out of the root zone, and improving nutrient distribution across the system. We do have a lot of work focused around biofilm removal and the role, not only from a research perspective, but on the applied side. There's plenty of examples now of the role of nanobubbles in the ability to remove biofilm from surfaces as well as inhibit scaling. So that's of interest. And then improving soil microbiology as well. We focus as a company, right now we're exceeding about 2,200 installations, about 51 different countries. We work with and collaborate with a lot of academic institutions, as well as a lot of these industry partners here. Really, again, it's utilizing these nanobubbles in a way that improve the efficiency of various inputs that go into a process. And when we're looking at the role of nanobubbles in agriculture, we really focused on the way that these nanobubbles can improve input efficiency. And that's kind of what we're going to be talking about a little bit in more detail. For those of you that are not familiar with nanobubbles, it's a classification of a scale of a bubble that's around 100 to 120 nanometers in size. And that's really on the left-hand side. If you look at where the virus and bacterium live, it's incredibly small. And what's unique about nanobubbles is that they can be stable in solution and in essence, mimicking the properties of a colloidal particle, rather than how we conventionally think about a bubble, which is produced and rising out of the column of water. This is, by comparison, much more similar to a particle that's stable in solution that moves around randomly because of their electrochemically charged surface. The properties and the behaviors at this stage are incredibly well known and researched. There's literally hundreds of papers out now that are done in all parts of the world that really look at not only the properties and behaviors and in all manner and forms and applications. And as it relates to irrigation and agriculture, we're mostly interested in the electrochemically active surface, which has this ability to reduce the hydrogen bonds in water and consequently can improve the behavior or water potential or the way that that water will move through soil and substrates. That's of key interest. As I said, this is a relatively new and nascent science, but it is advancing incredibly quickly. As a company, we do focus extensively on a lot of R&D. We have PhDs on staff that look at the fundamentals and all types of different applications. We work collaboratively with a number of different academic and third-party institutions, and everything that we talk about today is in some way, shape, or form being validated. And whether we're talking about biofilm removal or input reduction efficiency, water efficiency, infiltration, and all these plant benefit derivatives of that, again, have been well researched and validated. And as I said, there are new papers coming out continuously, and it's all supportive of everything we're talking about today. When it comes to nanobubbles and their sort of impacts and benefits as it relates to agriculture and irrigation, we kind of look at these 4 different pillars. And it really starts with introducing nanobubbles into water with the principal purpose of improving that water quality. And that means a couple different things. It can mean improving dissolved oxygen level in that water, or the oxygen availability. It can mean reducing the surface tension of that water. And it can also mean treating to remove or reduce algae, as well as certain pathogens that may exist in that water. And then with the introduction of the nanobubbles in that solution moving through your irrigation system, we're focused on biofilm removal, scale inhibition, all to improve emitter uniformity and distribution uniformity of that system, and also improving the hygiene of that irrigation system. And then obviously with these sort of improved water quality, nanobubbles in solution, reduced surface tension, we're focused on how that affects the distribution of water in the soil column, the effect on soil compaction, microbial activity, obviously reduction or suppression of pathogenic organisms, then the promotion of aerobic organisms that would be beneficial to root and plant health. And then plant health as well, just sort of really sound principles of, once we provide the plant with adequate oxygen, improved water and nutrient distribution, root health is improved, root mass and capillary root development is improved. And as a consequence, that nutrient absorption is more efficient and the plant is less stressed. And what we typically see as a result or derivative of all of that is an improvement in fruit caliber or vegetable caliber, as well as so crop quality, and consequently the opportunity for a yield improvement is right there. So we divide the sort of the benefits of oxygen nanobubbles into really 2 principal categories, specifically as it relates to oxygen. Again, these are all relatively known and well understood principles at this stage, but improving water quality, we know oxygen plays a critical role in plant respiration. We certainly know the extremes of it. Supersaturated soil with water can create asphyxia. So a lot of farmers are really familiar with that concept of asphyxiation due to oversaturation with water. So increasing the oxygen availability in that water is a way to mitigate some of those stresses. We know that introducing oxygen into the sources like reservoirs and canals has an ability to reduce the algae content in that water. And as I said, treating the water in situ at source is an opportunity to address some of those vectors for pathogens that would enter your irrigation system and consequently the soil. And then as it relates to oxygen in the soil and the root zone, we know now that oxygen plays a critical role in ATP production. So it's facilitating the nutrient absorption in certain capacities. It's supporting certain enzymatic functions with the plant, and all of that as a result, once those metabolic functions are improved, we see things like better stress resistance, better drought or stress tolerance to heat, and just sort of things like that. And part of that is you see metabolized in the plant in the form of the turgidity, integrity of the cells, and consequently the sum of those parts are improvement in the productivity, both in caliber and weight of the crops. So specifically on the science again, interestingly, if you look at a glass of water with nanobubbles in it, you cannot see those bubbles in there with the naked eye. You can certainly use things like a laser to refract off those dissolved particles in solution, but the effect on water and the way that it can change is something that's very easy to observe, certainly through like a capillary action test. And what we know is that there's a direct correlation between the concentration of bubbles that we introduce into the solution and the consequent reduction in surface tension of that water. So if you want to make an analogy, it's very similar to introducing a surfactant to a soap in solution, which is helping to relax those hydrogen bonds. And as a result, when you're looking at a droplet of water, you see that contact angle change. And by contact angle, you see more of a defined droplet compared to more of like a pancake droplet, which is going to improve that distribution uniformity through that soil column. And as a result of that, what we're trying to do is really change the ability for that soil to be flocculated. We're changing the distribution of nutrients, particularly those that are introduced through fertigation and dissolved. We want to make sure that those nutrients are adequately not only dissolved in solution, so we're preventing some of the precipitation that may occur, but also then distributing that uniformly through this reduction in surfactant. So it's almost like adding a penetrant, a non-chemical penetrant or an adjuvant to that fertigation or irrigation system to help mobilize, distribute those nutrients. And what I like to make as a sort of a nice comparison to think of is when you're able to dissolve those nutrients and keep them dissolved and suspended in solution and then distributed evenly, it's kind of like dissipating or distributing a cube of sugar. So that nutrient salt at a very sort of micro level is completely broken down and then distributed evenly, creating a much larger surface area in which that nutrient can be absorbed because it's distributed evenly in the root zone. Another thing that we track consistently now and we feel like is one of the most pronounced benefits of introducing nanobubbles to irrigation water is this ability to improve infiltration, particularly when there is compaction in the soil zone, and especially when you also have sodium accumulation because of that compaction. And so this is data that we're tracking with soil probes that go down to 46 inches, and we are observing behavior change in the way that that water moves through the soil column as a result of the surface tension reduction. And we're also looking at how that improvement in filtration is changing the behavior of salts that may accumulate in that soil. And so when you're looking at this particular two graphs here you have a control, two adjacent plots, all fed the same water source and same irrigation frequency and amount. And here you have on the left-hand side, you see in that middle heat map, you can see basically a lot of compaction in around the 28-inch mark, and that's basically showing how the water is not really mobilizing in there. And when you look at the salt layer in the bottom heat map, you'll see that the salinity is very high, and most importantly, you don't see a change in that salinity when if you're looking at the gray dotted line, when the irrigation actually stops, you don't see any change in that sodium levels in the soil. By comparison, in the side of the orchard that was getting nanobubbles, you can see a very, very distinct drop off as the irrigation has stopped. You see that drain down in the water going happening quite dynamically. And as a result, you see in the bottom heat map there, you see the salinity change quite significantly. So we definitely are very focused on how nanobubbles can be used and facilitated, not only as a way to improve this infiltration, but affect your soil amendment regime as it relates to improving flocculation, reducing soil compaction, then also your salinity management as well. Similarly, when we're looking at substrates, we see some similar trends in behavior in the way that the nutrient salts and the conductivity is changing and the water content. This is some strawberries, or raspberries rather, grown in cocoa core. And you can see the two lines, the gold being the conductivity, i.e. the nutrient salts, and gray being the water content. And you can see them trend very closely together as the irrigation system is turned on and off and nutrients are applied. And then when we start the nanobubble generator, we start to introduce oxygen nanobubbles into the irrigation water, you see that behavior change quite significantly. Very where not only is there a separation between the water content and the soil, but the conductivity start to stabilize in a way that is a lot more consistent. And this all has to do with the charge potential of the nanobubbles and being able to neutralize some of the charge sites in the cocoa and normalize the accumulation of salts or buffering in that substrate. Another thing that's well defined now, and we have 3 published peer-reviewed papers looking at this. There's a number of other papers as well, which are wholly supportive of nanobubbles as a mechanism to help remove biofilm from surfaces. Here we're talking about a mechanism or mode of action where you literally have the physical presence of the bubble in very, very high concentrations moving through piping and irrigation systems where they're degrading and penetrating biofilm to dislodge them and remove them and clean those deposits from the surface. Simple analogy to scrubbing bubbles, but literally a non-chemical mechanism to support improving the cleanliness of your system, so mitigating chemical treatments that may be salt-based, like sodium hypochlorite or chlorine. This is a very, very nice alternative to that is not only effective in treating and removing biofilm, but it's synergistic and complementary to all the other facets of growing, whether it be nutrient delivery, soil health, microbial activity in the soil. This is something that is very complementary to everything that one may do in a normal course of growing and farming practices. And then as it relates to climate smart agriculture and the model, and this is where Michael joins with a great deal of expertise and background, but we're focused on basically looking at all the properties and the benefits of nanobubbles and how this facilitates a much more sensible way of input use efficiency, obviously with the ability to improve profits in the ideal scenario, but really looking at rising costs in all inputs across the board, from agrochemical to fertilizers. Not only that, but we've just exiting a pretty significant drought conditions, so the cost of water in places like California has been exorbitant over the last few years. And the cost of energy, whether you're running your pumps on diesel or whether you are transporting goods to and from your farm sites. We're looking at the role of nanobubbles in helping to really improve input cost efficiency, reduce the cost to produce in some way, and obviously improving profitability in the sense that we can synergistically work with these inputs to improve not only the health of the soil, the sustainability of these practices, but also the productivity of these areas, particularly when those have been marginalized over the years. So again, relevant to the general overarching climate smart agricultural tools, we're focused on how nanobubbles can look at these different aspects of farming practices more in a synergistic, not so much as a replacement, but a way that you look at these core tenets of a climate smart agriculture, which is obviously with a vision towards a more sustainable practice for the future, and looking at how nanobubbles integrate into each one of these different aspects that are supportive of this philosophy. And, you know, specifically water use efficiency, reducing runoff, reducing input of fertilizer, making sure that it's distributed and dissolved and bound in the soil in a way that's beneficial and not running off. All of these are, if you look at the general practices that people working towards these objectives and sustainable practices, I think it's easy to see how connecting the dots and how nanobubbles can help facilitate and improve these different practices. Again, chemical free, it's one thing that we speak, emphasize and stress as an importance of this solution. The super nice part about nanobubbles are naturally occurring. They do occur in the environment. They've been around for a long, long time. We're just now observing and commercializing around that, and the way that we're doing that is producing these in significantly higher concentrations and introducing them in a very dynamic way that is supporting, particularly in this case, irrigation and cultivation and agricultural practices. As Michael was saying at the top of the webinar, is that there is some level of agnostic behavior to whether or not we're putting this into different types of irrigation systems. What we see here, and what I'll sort of go through in a minute, is looking at how these nanobubbles can be applied in a whole variety of different crops, and we definitely see very consistent behavior irrespective of the irrigation or cultivation method, but also the crop type. And again, that points to some of these principal mechanisms that we're utilizing and obviously capitalizing in a way that it makes sense. The only variable that we kind of look at in terms of crop type and cultivation method, i.e. irrigation method, would be the role and the quantity of oxygen that we may want to introduce into a solution. So we have some more controlled environments where we focused on supersaturating and increasing the amount of oxygen to a much higher degree than we would typically for an orchard in the Central Valley that's growing nuts, and we need to focus more on soil compaction and salinity management versus high quantities of oxygen that may not be conducive for that kind of environment.
The way we work is on a consultative basis. So when we interface with a grower through our dealer network, we like to set collaboratively a set of objectives. What is it that the grower wants to achieve in a brainstorming kind of way? Is it reducing the reliance and the volume of chemicals used for cleaning conveyance, drip lines, emitters? And a byproduct of that, of course, is better nutrient and water distribution? Are you really interested in reducing compaction and adding oxygen? After all, agriculture needs 5 basic inputs. We know labor, energy, but water, air, and soil. With all due respect to hydroponics, we know that the majority of the growth, of course, has to be with soil. And the one that's really kept out of the equation too often is oxygen. If plants experience hypoxia, the oxygen deprivation in the soil and in water, we all know that the enemy of agriculture is compaction, and bringing oxygenated water to the rhizosphere, to the root zone, could be a very major objective of a grower. Is it to improve EC in the soil? Is a grower more interested in leaching salts out of the ground after finishing an irrigation regime? Is it increasing fruit caliber, cluster counts and weights, greater volume and size of nut meat? Is it improving capillary action of the water? Is it improving the microorganism population in the soil? So these are things that I think most growers are interested in. So Warren has said it, it says it on this slide, but we are able to offer these, fulfilling these objectives in an entirely chemical-free way, which leads to ESG investments. So I will stop there. We'll pick it up a little later. Thank you, Warren.
Excellent. Good points there, Michael. So yeah, so kind of a perfect segue to this is, you know, when we look at just some of this may seem a little bit ambiguous, but really when it comes down to the application of the technology, we operate in kind of 3, maybe 4 different domains. One in a sort of a very controlled manner, you know, if it's CEA or controlled environment agriculture, we have some sort of stored water tanks that's brought in. We may recirculate on that water to supersaturate it, and that makes sense, again, to what Michael was emphasizing there. Depending on the crop type, depending on what the objective of that grower is, we may tailor the solution to achieve those objectives. Similarly, where it's an outdoor reservoir, like the second picture from the left here that we're looking at, which is a large berry grower in the Central Valley, Central Coast area. It's an outdoor bladder. Water comes in from the well. It goes into this million gallon bladder, and we're treating that water before it goes out into the irrigation system. In Chile, for example, we have where reservoirs are used extensively. We're often recirculating the water in those reservoirs as well as a form of pre-treatment before it goes through filtration and into the irrigation system. And then lastly, which is probably the most applicable for a lot of California, which is an inline system, which is ultimately just going downstream of your filtration system, in between going out into the, whether it be the drip or center pivot. And there we're introducing the Nanobot Air nanobubbles or oxygen nanobubbles, again, depending on the application. And that is specifically focused on, again, whatever the crop type and deliverable is that we're working towards, would be how we're sizing the systems. And again, the system is, because this is an aqueous solution-based system, we're sizing our systems based on the water that we're actually treating. So that can mean a volume of water in a reservoir, in a tank, or ultimately it could mean the gallons per minute or cubic meters per hour that's going through a pumping system. And we're focused on how much water we're treating and how much time we have to treat it. So just to sort of keep up with the pace here so we have enough time for some questions and answers, we kind of like to stress, we now have hundreds of installations in different parts of the world. Michael has joined Moleaer to really help focus our efforts in California. This is an incredibly important market for us. And there are so many applicable things that we know we can address, from salinity to soil health, to various different crop types, where we know that and believe at this stage that, or at least it's been demonstrated, that nanobubbles can have a certain value. And the really neat part is, even though we tailor the solutions to address certain things within that growing practice, what the results of that, what we see, are fairly consistent irrespective of the crop type. And just starting with strawberries, oftentimes we have a poor water quality. Sometimes it could be the hardness of the water. Sometimes it could be algae and pathogens. Those can have pretty significant impacts on soil health, particularly as the growing practice and the regulations around methyl bromide and things that you may have to treat to the soil become more stringent. We're looking at this as a way to work a little bit more synergistically with maintaining soil health in these types of environments. And when we get it right, and we're able to introduce the right amount of nanobubbles and the right amount of oxygen in these systems, the effects on plant growth and productivity can be quite substantial. In the case of Grupo Altec's project that we did down in Mexico, where after treating their reservoir water, they saw a 41% yield improvement. Now, you will notice that we don't emphasize yield improvement. That is a derivative of addressing these various different pain points or challenges within the irrigation system. But once we effectively address it, the effects can be quite pronounced. Pathogen control in the root zone, whether it be substrate or soil, is something that we consistently see as a pain point for growers, and we're looking to use these nanobubbles in a way that is promoting the beneficial bacteria as well as suppressing pathogenic bacteria. That's really about, obviously, improving the flocculation of soil, bringing air into that environment, as well as supplementing with additional oxygen from the nanobubble technology. We've done quite a bit of work with orchards, citrus, almonds, and specifically avocados and cherries extensively in Chile and South America. Our growth rate has been quite exponential down there. The benefits are obviously very well recognized, and we've seen an adoption rate pretty quick. What we're consistently seeing is an improvement in the caliber, particularly the largest caliber size range of these fruits. In the case of citrus, we saw a better maturation of the fruit grade and consistently of that ripening. And then in the case of blueberries, again, we're doing a large amount of work, a large body of work down in Peru and Chile, working with companies like Composol, one of the largest producers in the world. And again, these are now in the second and third seasons of commercial systems in the field, producing consistent results in yield improvement and caliber size improvement. We've again worked extensively with leafy greens, more in the controlled environment side as well. But we have situations where customers have also used our technology to support treatment of reservoirs that are feeding leafy greens, where there's concern about foodborne illness and contamination coming from that source water, and as well as just treating the irrigation system for improving uniform distribution uniformity as it may result from biofilm in that irrigation system. Peppers and tomatoes are areas that we've also worked quite a lot with both in soil and substrate. We do a ton of work in the south of Spain as well, area called Almeria. And again, looking at introducing oxygen nanobubbles to promote the oxygen availability in the root zone. And again, what we see is is, as a derivative of that, a much healthier root mass, significantly better root structure, capillary root development, and then as a result of that, you're seeing better vegetative growth, and you're seeing better fruit development. That could be fruit setting, and it could be in just the maturation of that fruit into these larger caliper sizes, which is obviously substantially more valuable to the customer than yield alone. And again, reservoir treatment, it could be algae control, it could be pathogen control. A lot of the times it's to offset chemical use in a way that may fulfill a better ESG initiative of being more complementary or synergistic with some of these other things. So whether or not you want to move away from things like copper sulfate or your salt-based sodium hypochlorites, things like that may have a sort of negative downstream or cumulative complications further down the line by continued use. This is something that, again, is just to stress what Michael was saying. It's a non-chemical method that just works much more complementary with all the different modalities and different ways that we're approaching irrigation. And to conclude, before we get to the question and answers, again, safe and chemical free. The risk of getting something wrong with a technology like this is incredibly low. We're really looking to enhance all these different aspects of cultivation and growing crops. And that starts with this very small nanobubble that has this charged surface that can do some very, very interesting things in terms of changing the behavior of water. And that's the way that we're trying to harness this dual action of using that as a vector to deliver some of the gas into solution, to promote the bacteria, to promote soil health and root health. And as a result of that, we're looking at ways to introduce this in all types of different systems, as I said, whether it be inline or reservoirs, the flexibility to install these kinds of systems in different ways to address or accommodate different kinds of irrigation systems, different kinds of pumping and flow rates. There's a great deal of flexibility for integration. And we're based in California. The company is headquartered here in Los Angeles. We build and manufacture everything in California. It is a patented technology, but it's incredibly well supported. So we do bring on people like Michael that are domain experts in this. And as I said, we're working to solve, could be unique solutions, but a lot of these are very common in California. But we're looking to apply this in a way that benefits not only or addresses the issue that you're facing, but helps you move towards a more sustainable ESG practice that fulfills this goal of a climate smart agricultural practice that is obviously going to be more sustainable into the years to come. So with that, Michael, I will turn it back over to you. I appreciate everybody's attention through that, and let's see if we have any questions.
Thank you, Warren. We do have a couple of questions. Elson in Hawaii has the first. Warren, can nanobubbles mitigate nematode issues in the soil that attack drip irrigated crops through the plant's root system?
Yes, but more in an indirect manner. So nematodes is frankly not something that we focused extensively on over the last few years. But what we do know is that when we improve the environment in that root zone, that creates more of a beneficial microbial activity that's more conducive to and healthy growth, that can abate some of the nematode issues. So in a past life, we used to look at using certain types of beneficial bacteria to address nematode issues, and that was very effective. And in the same vein, I would say that rather than trying to use extensive microbial inoculation through supplementation, there really is an opportunity for enhancing the endogenous bacteria that's already native to that soil environment, that's acclimated. And again, when you look at some of the research out there, you see a very interesting transformation in the microbial activity and the emergence of certain dominants of beneficial organisms that really help address certain things, whether it be toxic root exudates or nutrient fixation, things like that. All of that ultimately, when you attack it from more of an integrated practice, is the way that we can abate the nematodes.
Elson, if you want to respond, please, well, first of all, write a note, and if we have time, we'll come back and invite people to unmute and open up, because I think it's an excellent question, but I do want to get to the other questions first. Jim asks, does the technology have any incompatibility issues with any fertilizer and or pesticide applications via the irrigation system? For example, that is precipitation or chemistry degradation, as well as biological inputs.
Yeah, it's a great question and a very relevant one. So in actual fact, very interestingly, what a part of the area of R&D that we're focused on at the moment is looking at the role of nanobubbles to inhibit precipitation. So probably those of you that grow are familiar with an issue when you have a certain hardness in the water, or a certain level of hardness in the water, that can facilitate the precipitation of your phosphates. And obviously that's not desirable. And so what we're looking at is the role of nanobubbles in a much broader capacity to inhibit precipitation of salts. And that can mean a variety of different salts. It could be sodium or potassium or calcium nitrates and phosphates as well. And that's where we think that there's actually an enormous opportunity for nanobubbles to inhibit precipitation and keep the nutrients very well solubilized, and then obviously distributed more evenly rather than having deposition in your irrigation system with certain larger tributaries or sort of capillaries in the soil, but really spreading it out. And that provides less opportunity for nutrient runoff as well. And then, sorry, the second part of the question in terms of incompatibility through oxidation, no, none that we've observed to date. Again, when you look at the oxidation potential, even though there is some potential there when we stimulate a collapse of those bubbles, that is by intention. Typically, the oxidation potential that we're introducing here is not to a degree that would affect the nutrients in any way.
Thank you, Warren. Let me just add before we get to the next question, and we did add 15 minutes, so we definitely want to cover all questions, not leave anyone aside. Just to extend what Warren said, one of the things that most attracted me to this company is I consider this a hyper disruptive technology. And what I mean by that is that besides providing answers to critical problems, Moleaer also offers what we call an enabling environment. We're not producing any amendments, fertilizers, but what we are doing is providing added value to all those amendments, all the other chemical amendments you might be providing, all the fertilizers, mycorrhiza, whatever it is that you're applying. We welcome, first of all, collaboration with these input providers. And we think that you will make greater benefit, meaning greater efficiency. If we relate to water use efficiencies, the amount of water we use to create a kilo of dry matter, for fertilizer in particular, with the costs going up, if you do that same calculation, you'll see, I think, that by using nanobubble technology, that ratio will significantly increase and improve. So again, it's chemical free. And let me get to the next question, which is that we've mentioned many benefits of this technology. Please describe the disadvantages or the weaknesses of the technology.
Good and fair question. So I'll answer in two parts. So there's many different ways that you can make nanobubbles. Each one has its strength and weakness. So as it relates to nanobubbles specifically, the weakness is potentially, I would say, related to cost to produce and efficiency in which it can be integrated into a system. So we know concentration matters. And so there's a threshold where you're going to achieve a certain effect. So the weaknesses are being able to do that at a scale, and by scale I mean thousands of gallons per minute, in a way that's sustainable, reliable, and cost-effective for the market to bear. So we talked a little bit about the role of oxygen versus air, or the oxygen content. We have probably 80-90% of our applications are oxygen based. But then that may not be feasible for a lot of customers to go to that additional capital expense to utilize oxygen. So there we're looking at the role of oxygen, I mean, of an air nanobubble, and that's where you'll hear us focus a lot more on surface tension reduction, soil compaction, soil management, soil flocculation, and those things, and lesser to a degree about significantly elevating the amount of oxygen in the soil. So one advantage that we have as it relates to Moleaer and the way that we're doing is that when we were looking at these different ways, we sort of gravitated towards the benefits that this could bring, and particularly in irrigation and horticulture. But some of the guiding principles of why we adopted the style and method of production that we did was just looking at the scalability elements and how could we do this at a particular scale that makes it relevant to water treatment that's treating tens of millions of gallons per day, or an irrigation system that's pumping at 5,000 gallons per minute. And so when you look at it from that lens, you see that a lot of the alternatives ways to produce nanobubbles are very limiting or just not applicable. So our distinct advantage is that we have developed something that's scalable, that can produce a certain concentration of nanobubbles that can create an effect to like which we've just described at a scale and a cost that makes it realistic for commercialization in California. And I think just because I see it here, Michael, and I'll touch on it, Gez is asking, so how do we, because it's related, we produce our nanobubbles through a hydrodynamic diffusion process. And again, the reason why we have adopted that is because of this limitation of head loss through a system. So when you're looking at the irrigation system, as I said, we've got this evolution of treating the water at source, and then ultimately the degrees of treatment when you go further and further into your irrigation or the field, you have accumulative head losses that are potentially there. So we work with this hydrodynamic diffusion process because typically the head loss is manageable, and it allows us to go into these different form factors that can go in line, and again that allows us to provide this reliable as a relatively high concentration of nanobubbles. And again, for us, even though we're talking about treating irrigation water, which is relatively clean, we work with incredibly dirty water as well, and industrial and municipal wastewaters, and the technology has to continue to work in these environments. So if you've got very hard water or you've got very dirty water that has biology, we have examples where customers are looking to reuse wastewater for irrigation, and that can be complicated. We want to make sure that our process is going to continue to work in these environments.
Thank you.
Any other questions?
It's not an answer to the question about the disadvantages, I'm sorry, but one of the other advantages we didn't talk about too much is where we place the units in terms of where the pump is, where the filter is, et cetera, et cetera. So anywhere that we place the unit, everything downstream of that, and it can be your filtration system, given circumstances, it can be your conveyance system. Everything is going to benefit from being treated with what we call enriched oxygenated water. You will see a reduction of scaling building up on the seals of your pumps, for example. And I must say that this is a young technology. Moleaer is not a startup, but it is a young company. And we haven't yet seen all the list of areas that we can impact positively. If there's areas that we see going forward where we would like to take a step back and say, we're not sure about that, or maybe there's things that we haven't anticipated yet, we are in our method of reaching out to customers is education, is conducting workshops, is inviting people to our facility and being as transparent as we possibly can. We don't want anyone to invest in a system where the outcomes are not projected, at least, to be positive and significant. So we're young, so we will learn as we go on. That's all I can add to that question.
Very good.
It's 11 o'clock now. Other questions? We're right on time. You obviously, we've deluged you with invitations to this webinar. So you have all of our email addresses for sure. You know how to get a hold of me. And what we would like to do in summary with any of your clients, whoever they may be, and they may be corporate clients, they may be smallholder clients, they may be, again, different crops. We know how oxygen dramatically helps all the crops that we've addressed so far. Call us and let us come and meet with you and collaborate and conduct workshops at your facilities and at your growers' facilities. And on a one-to-one basis, I'd be happy to talk to you about our pricing structure. We think is also unique and creative, and I think will please the growers and our dealers. So if there's no other questions, this, as I said in the beginning, is being recorded. So we will file this and make it available. I'll rely on Jen to get out the recording link to all of you who request it. And Jen just remarks that she also thanks everyone for attending, and we will share the recording soon. So I thank you very much, and we look forward to collaborating with you any day, anytime.
Thank you all. Appreciate everybody's participation. Very good. Great rest of the day.